Hello and welcome to today's Ceratec Customer Enablement Series. My name is Sarah Utsugi and I'm the Marketing Coordinator at Ceratec, and I'll be your host today. Presenting today, we have Ceratec Senior Applications Engineer Mark Anderson, and he'll be talking to you about NX nesting and what it means for NX CAM. Our CES sessions run about 30 minutes each, sometimes less and sometimes more, and they're all recorded and posted to our Ceratec YouTube channel. You'll find all of our past sessions there. We hope that you continue to join us here twice a month to share ideas and learn about tips and tricks that will help you in your everyday tasks. This is a live session, so please share any questions or comments during the presentation by submitting them in the questions box in the right-hand panel, and Mark will be happy to address them at the end of the session. All right. Hi, Mark. Thank you so much for joining us today. Can you tell us a little bit about yourself and what you do at Ceratec?
Yeah, sure, Sarah. My name is Mark Anderson. I'm a Senior Applications Engineer at Ceratec. The bulk of my experience is in actual manufacturing production and the implementation of CAM softwares, anywhere from medical through gas and energy, pretty much any type of manufacturing you've done. And at Ceratec, I specialize in the CAM products that they provide.
Great. Well, we're excited to hear what you have to share with us today. Why don't you go ahead and share your agenda and take it away?
Okay, thanks, Sarah. So we've been waiting a very, very long time for something like this to come into the NX environment. Any type of beam machine, whether that's wire, laser, plasma, a 2D machine, it's more commonplace in the industry to see onboard logic where you're using an AutoCAD system or some type of drafting design system to layer your work so that the machine controller can interpret that when it comes in, whether that's a pierce or internal cut, external cut, fine finish, rough, that type of thing. So there was no true associativity between any of those types of manufacturing processes. So it was commonplace for that type of manufacturing to be left out of NX. Customers, even though they were using NX, they did not implement using NX for those types of machines, just because it added a little bit more work and a little bit more complexity to something that was very streamlined in the beginning. So now NX has came out with this tool that not only does it do the nesting of your part products, but it does it intelligently. It will take the entire project, whether that has multiple types of materials, multiple thickness of materials, it will plot out the entire project on whatever sheets that you have in inventory. It also intelligently keeps track of your drops, what is left over after the material. You can cut it and then take it into a library, and then once the automation process is taking place, it will then choose that drop, or it will give you a selection option to choose that drop. It also has intelligent positioning. It will position the parts in multiple locations. You can give it a multiple array of parameters to be able to control that. And I'll show you that a little bit later on when we go through the demonstration. So the overview is, this is an exclusive function to the sheet metal module. You cannot do an add-on for sheet metal, but the majority of the CAM/CAD bundles that are out there have this already included in it. So just keep that in mind, that this is a sheet metal process, but it directly relates to NX CAM now. So if you have one of these higher level bundles like Total Machining or Advanced 5-axis machining, this capability is already in your platform. And if you wanted to add this, you would have to add a CAD bundle that included sheet metal. Excuse me. I'm going to show you how to use the new 2D nesting tool to create the DXF files for water jet, lasers, or other types of streamer wire machines. I'm going to show you how it quickly nests all the parts of an assembly, regardless of the thickness of material. You can use this for your planning management, to where you can process an entire build, an assembly of multiple products, multiple thicknesses of materials, and it will plot out how many sheets you need for each thickness of material, kind of material, things of that nature. It also has stock management capability and drop management capability. Then we're going to take it a little bit further. So the first two items that I discussed, you can implement that without taking it into NX CAM. You can keep your current system of using the layer settings to take it right into your OmniMax or whatever control you have, and it can directly interpret that. And we can control the layers for the output that we create that file. But these next three are taking it to the next step with the associativity factors of NXCAM and the automation of feature-based manufacturing. Then we're going to discuss what are the roles of PMI in this process and how does PMI drive this from the very beginning. And my goal for this demonstration is to show you that the current system that you currently have, yes, it's functioning and it's not broken. But what happens when we try to take this into the current system that you've already used to have the associativity availability? What happens when you currently have an engineering change order? How long does it take you to process that change, process your sheet planning, and all of those items that you need to keep track of before you're actually cutting chips again? By bringing it into NXCAM, we have that associativity factor, so we can use our replace component functions, and we can do a direct output and a reconfiguration automatically. So it's going to, there's no doubt, because we're adding more to the structure of how you're programming. The current system you're using is disconnected from even your CAD system. If you make a change, you have to reprocess everything. To start this in NXCAM, yes, there's a little bit more upfront work and a little bit more upfront structure in your files. But when you really see the benefit of this, when you get a change or you get something that needs modified, and you can see that associativity perpetuate down to the DXF file. So we'll move on to the nudity testing. So the process begins with the sheet metal part is created, and then you have to create a flat pattern. The flat pattern is what is interpreted into the nesting function. You don't have to just use DXF. You can also use a part file. The part file just has to have all the configuration set up in it first. You have to have the flat pattern generated, and you have to have all your materials, thicknesses, all of those parameters set before you can start that as a part file. So if you have DXF files, they'll directly translate through, no work needed. If you have your NX part files, then the designer will have to thoroughly fill out all of the information pieces, and then we can directly use that part file in the same exact manner. So what I'm going to show you today is taking a part file, exporting a DXF, because that's more indicative of what is the most likely scenario you're currently using. But this directly applies to if I were to use a part file. Using a part file would be a better solution, because that part file is then, if it's updated, then the part file can directly translate out into the sheet. If you use a DXF file, you have to reprocess the sheet. So the tool that we're going to use, it optimizes the part configuration. It intelligently plots the part orientation to provide the most efficient sheet layout. And we have direct control over if your parts have grain direction control or things of that nature. We can lock them in position if we choose to. And the nesting function, it plots the parts, materials, and the sheets in an organized DXF file or a PDF file that you can carry through to it creates like a shop documentation type of product. So the first thing we're going to discuss is the first process of this is most machines have a set parameter or a set layer that's going to define what type of cutting it's going to do. So layer 0 is generally a rapid motion, layer 1 is a pierce, so on and so forth. So this is where we would set those information up. We would just make sure that these items correlate to what the machine is going to interpret. Now, when we're talking about feature-based manufacturing, we would set this to layers that we could then define in the feature-based manufacturing knowledge editor to say, whenever you come across a layer 2 item, and we would have to give it another attribute, say a color, we could make it to where all exterior features are magenta with a layer of 2. So then in feature-based manufacturing, we could say, anytime you come across a magenta feature with a number 2 layer setting, that's always an internal trim with these cutting parameters, this operation type. And that's how we would automate the system. So this is just defining your secondary process, whether it be the machine or NXCAM, how it's going to interpret those items. Then we have our nesting settings. So we're just going to run through the nesting direction. You're going to orient the starting point on the sheet of where it's going to start the process of the nesting. You have your edge distances and your part distances. Excuse me. And as you guys know, for the people who run these types of machines, there's a constant problem of your beam is going to deflect. no matter what, it's going to deflect a little bit. So if you get too close to a prior cut, it will stop cutting the part, and you'll have an error there before it starts back into the material. And then where it says cut layer and attach layer, so you're cutting layers that are going to force the system, whether your machine or NX, to produce cutting motions, would be in that layer. If you needed to do multiples, 1, 2, 3, 4, it's just 1, 2, 3. Attach layer is it will attach the geometry, but it'll all be on the same level. So when you bring this into NXCAM, this right here would have layer 1 is your cutting, and then attach layer 2 would just be geometric data. Then you have your nested input files. Once we create a standard, we could save it and then reapply it to the next parts. And then these are just your library for your stock and your output directories. NX comes with a pretty detailed stock configuration, but it's very simple to add new sheets to that. Now we have our stock settings. And once we define our stock settings, so you can see the process at which we're building the ability for it to make a calculation at the end from the previous 3 tabs. So there's a couple different methods in the define stock. There's custom, you can create your own. And then this would be just keying in numbers. But then in that dropdown, you also have the library information. Then you also have another layer that's custom, which you would put all your drops in. Then on the right-hand picture, you see we have a lot of information. Once we add the stock, it's telling us what the size is. The format is custom. I didn't define material. Thickness is quantity. So if we had multiple sheets in the library, it would tell us that we had that many. So from a quoting standpoint or a management standpoint, if we can provide a data sheet that says for this particular job, I need 10 5/16, 22 10 gauge, and you could build your material list this way. So then we have our part settings. And as you see here, I have 5 different parts in there. So all I did is I selected an entire assembly. It loaded it into the graph here, and it's telling me that I have one piece, it's a negative status. So it's because it's telling me something is not right in this dialog. But if I were to have everything defined, it would tell me everything I need to know here. And this is building a spreadsheet in the background so that when you process it, it creates that PDF file. Then we have our process settings. So the first line you see is a processing time. So NX is, when you hit process, NX is going through thousands and thousands and thousands of different solutions. And it's trying to find which one of those solutions meets the parameters that you've given it, whether it's minimum distance, minimum material. If you have a part orientation locked, then it's going to have to give it different types of nesting. And it's trying to figure out which one is the most efficient. And you can minimize that time so you don't have it searching for another solution for so long, or you can maximize that time. You could put this at 60 minutes and it would run through different iterations of your nest to find the most efficient. So that's for increase or decreasing the amount of time you give it to solve it. The next is our spreadsheet data. We have rank, it's going to cut 1, 2, 3, 4. This is how much material it's using, how many parts it was nested. Now, say we ran out of material. Say we only have 10 5/16 in stock, but this job is going to take 12. Well, we would see the parts nested would be incomplete from the total that we needed, and unplaced parts would show numbers, and we could then say, oh, okay, we have to get more material. Then we have our nested stocks. It's saying that for this one particular part, the cut length is 50, utilization is 1.19% of the material. So there's a lot of information in this. It's not just a simple nesting tool. It's a very complex and sophisticated nesting tool. So let's do this demo. I'll open this part here, and I'm just going to run through the process at which it takes, the entirety of it. So there are a few things that you have to do in the very beginning. I have a sheet metal part. The sheet metal part must have a flat pattern. So what a flat pattern is where am I going to pick that it's going to be the standard surface that everything else is going to be bent to. So I come here to my flat pattern. I'm going to select this surface. That means everything is going to be bent to that plane. You see it bent it. This is telling me it created a view. Now, if I come over here into my views, this shows me my bend points, locations, and the flat pattern. So once I have this, I can export this flat pattern to a saved location. I have some setups here that I can, or some options that I can choose. Now, once I have this flat pattern, I'm just going to open up a new sheet metal file, because I don't want to embed anything in the part file itself, because that defeats the whole associativity factor. You only want the information that that particular function needs to have in it. So modeling needs to have only modeling. That's why we don't go in from the modeling environment, go directly application to manufacturing, because that's now violated the master model concept, and we lose a ton of functionality. No more wave geometry linking, no more synchronistic modeling. You do not ever want to manufacture in your model file, do your sheets within your model file. You always want everything separated and linked to back to the other file. So we're going to choose a sheet metal part. I'm just going to call it sheet metal model. Then right here is our nesting tool. We're going to come up here and use the nesting. I'll shrink this, or expand it, I'm sorry. So we're telling it, what do we want here? I'm going to start from the bottom left corner, 1/4 inch in between parts from the edge of the material, and then 100 thousandths in between any entity of a part to another part. And then we're telling it our cut layer is 1, but I'm going to tell it that our cut layer is 2. And then I'm going to attach 3 and 4. This is the library at which I'm going to choose, and that library lives inside your hard drive here, 2007 UGI materials. Then I give it a location to save to. Now, the previous icon, or the previous in the slide deck, I showed you about the preferences. So we want to come in here and we want to make sure we set these preferences to what we can either make NXCAM go faster with, or our machine control understands. So I really don't, there's only 3 items in here that are relevant to me, unless you do those types of things. So I'm going to make this layer 5, which is not what I'm going to include. I'll do layer 5 for the bend down, bend tangent. I'm cutting things, I'm not bending things, so I don't really care about those parameters. Now, outer mold, inner mold, exterior. Even though it says mold, it's still an outer feature. So then I will leave that as cut. Inner mold, I'll leave that as cut. Exterior cut, interior cutouts, cut. But what I'm going to do is I'm going to I need a differentiator between exterior and interior so I can drive operation processes. So outer is going to stay 1, inner is going to be 2 now. Exterior is 1, inner is 2, inner feature 2, center mark, don't care, 5. Hole features 2, lightning holes 2, 5, 5, 5, and 5. So now I gave it parameters to where I can separate things. And I'll show you why I chose this method when I go into the CAM process. Okay, so I gave it these parameters, gave it save locations. Now I have to tell it what stock I'm doing. So this is basically like feature-based manufacturing. You're telling it, what am I working from and what am I getting to? And it'll cut all the rest of the material out. So I'm going to add some stock. Now, just running through this so we can see it, this is pulling from that library I just showed you. Standard lengths of materials, standard widths of materials. And if you had your own stock list, they would show up here as well. Like you could create your own drop downs to where it would say 1010 material, 4140, whatever, D2A2, whatever you wanted in there, whatever your particulars were. You have thickness, physical materials. You have a lot of options in here, and these all drive processes as well. So if what you're choosing here is going to define an attribute in the material, or the material list that you produce through nesting. So that's why if you use a part file, you have to have all the attributes correct before you could use it. So we have a lot of different selections here. For our purpose, we're going to use a custom stock. I just gave it a 50 by 50. And this is, I'm not sure if anybody knows this, but you can type numbers that are different, the opposite measurement than what you're in, and it knows exactly what that is. So if I were in a metric file, I could type in 1 inch and it would be correct. So you'll see now it changed it to 1.1181. So now priority, we have different priority options. We can now add a part. So I chose DXF. Right here we have part files. I'm going to select the DXF file that I just created of that flat pattern. And now I've loaded it into the system. It's now looking at this and saying, this is my part. DXF was the original format. I don't have any material. This is the thickness. Here's my quantity. Rotation, 0, 90, 180. I can lock it in position depending on grain. Priority, I can tell it that I have to do these first. I can have to do that second. So what you're going to do with priorities is, say you had very, very large parts coming out of a sheet, but you also wanted to put smaller parts in the gaps. Well, if you go cut the big pieces out first, your sheets may warp and move, and you have dangers of hitting heads and things of that nature. So you could say, I want the lowest priority on the large items and the highest priority on the small items. So you have sheet structure. Okay, so now once we do this, say this part, we need 50 parts of that particular. Now, if I went through here and I put in an entire assembly, you also have another option, a batch quantity. So say I need 50 of these Craftsman toolboxes. Whatever parts list I have loaded here, no matter what thickness is, if I put 40 here, it will give me 40 quantities of however many quantities the parts are. So it would plot out the number of builds that you need, and the quantity of parts would be what it needs in the particular build to build it. So if I need 5 items of this to complete the assembly, but I need 40 assemblies, then I would put 5 items here and then 50 here. So for this demo, I'm going to just say 50. Now let's go into processing. So this is our nesting processing time. We're telling it only takes 60 seconds. So it can do millions of configurations in 60 seconds. But say I had something that was, say I was working with niobium sheet, tantalum sheet. Every single spec of that stuff is very, very expensive. So I would want to put a processing time of, say, 5 minutes. I would want it to go through every iteration it can, every algorithm that it could, to be able to pick the best option to save the most material. For the demo, I'll leave it at 60 seconds. So here's our start button. We're going to go ahead and start processing. What it's doing is running through those different iterations. And this particular takes about 30 to 45 seconds to do the configuration that I'm going to show you. So while it's doing this configuration, let's discuss the different items that we have over here. So if you were to use this in a realistic environment, you would be pulling your stock from a library that houses all of your materials, incoming materials, and drops. So then you would just save the drop file into the material list, give it dimensions so you could easily pick it. It does also have a preview so that you could see directly where you cut it. The only thing is it's still manual to create the cut line on the drop. So there's no function that says produce the drop. But once the drop is produced, then you can save that material into the library. A couple questions that are very common with this demonstration is, are my parts associative? So yes, they are, but that's a double-edged sword. So as you know, as soon as you kick out a DXF file, everything is dissociated. So there is no associativity to this particular sheet file here. And you're always kicking out a DXF file from this process. You're not saving a part file. So if I were to have an engineering change, then what I would have to do is I'd have to reprocess this. I would do a replace component, then I would reprocess the sheet. So the sheet is not associative, but the part is still maintains associativity. So all that needs done is a reprocessing of the same parameters. So you see I chose 50 parts. It did the configuration as best I could with the parameters that I set. It says utilization is 59%, 50 parts, only 1 sheet used. Telling me this is my sheet. my cut length, utilization, parts. So now what I could do is I could take this, when I hit OK to this, it's going to do a few things. It's going to save out that DXF output. Now it's gave me this nesting PDF. And what this nesting PDF does is it holds all the information, the stock details, number of parts, the cut lengths, and it gives you your visualization. So now it also gave me a nesting sheet part file. Gave me a nesting sheet DXF file. So now if I go in here, open up that part file that it created. If I were in the first option where I'm not going to take this into NXCAM and stay within the PLM environment, I'm still going to use my onboard logic that works off of layers, then you would just take the DXF file out to the machine. That simple with NX, but always remember, so now, right now, NX and your current software are apples to apples. Where does NX shine, and why would I want to add a little bit more complexity or a little bit more work to my job? I'm going to show you the reason why that 5 minutes or that 10 minutes of extra work is going to be the reason why you would want to bring all this into NXCAM. So we opened up this part. This is my configuration. Now, the reason why I did the layers the way I did is because I wanted to be able to have something to distinguish the items so that I could pull this information from Feature-Based Manufacturing if I needed to. We could use that information to drive logic. So now we're in NXCAM. Now we're just going. So this is the DXF file, or the part file, I'm sorry. So now we go into NXCAM just the same way as we always do, create the master model process. File new, we're going into the manufacturing tab, we're going to create the general template. General template, save locations, everything is identical, part to reference. Now that we've created this manufacturing file, I'm going to go ahead and start to program. Now, if we built this into feature-based manufacturing, I'm not sure if anybody watched the last two feature-based manufacturing CESs that I've done, but when we go and find features, it works off of the model. It doesn't work off of geometry. So we would have to build a process to where it now looks at geometry as identifying features. And then you see how it built different layers. The outside is one layer, the whole is another layer. So it would choose outside profile, inside profile automatically by 5 clicks of a button. So that's the automation portion of the programming. To show you how it works, there is no need for workpieces or anything like that. We would want to set our MCS at the correct corner, but I just want to show you processes. So we would just create an operation. I'm going to use Wire EDM, the same technology. I don't have any tools created. So we're going to go ahead and grab one from the library. And of course, if you were doing this in real life, you would want to be much more accurate than I'm just demonstrating. So I'll grab this 8-thou wire. So now what I would do is I specify my wire geometry. I'm just going to do this on one part. So if I were to have done this slightly different when I exported the DXF and claimed these different features as different entities, then in the layer settings, I could hide layer 1 and show layer 2 and just do a wide box selection like this of all of the features. And then I could create an internal off of that. I didn't do that, so I'm going to have to do this manually. So I'm only going to show you a few parts. So we're going to select curves. We'll check connected curves. Now, anytime that you jump off of your feature to a new feature, you want to hit add new. If you're inside of a feature, like say your tool doesn't have to jump over to a different location on the part, it's fine just to keep selecting. And there are circumstances where you could select every one of them in one, and it does things fine. I've just found it better for NX's computation ability to do it with adding each individual closed feature as a different item. So now I'm just selecting a few parts. So now I have all my toolpath. So now what would we do with if you had start locations, or what if you had lead in, lead outs that you needed to do? We can automate that entire process. That entire process can be done to where all we have to do is come over here and hit find features. We haven't turned this on, so it's going to tell me I can't do it. But that was one click. Tell it what we want. We would say sheet metal, internal, external features. 2 clicks. It would then find the features. Right click, group features. That's 5 clicks. Right click, create feature process. 7 clicks. 7 clicks of a button. We could do any complexity of a 2D nature that could ever be. So you could automate this entire process and never have to do more than 7 clicks to program any type of wire, laser, plasma, anything like that. And I'm talking 2D and 4D. So 2-axis or 4-axis, it's all the same thing. We can automate all those processes. We just cannot automate the full 5. Okay, so after seeing the demo, I want to talk more about what does this mean for NX CAM and feature-based manufacturing, because that is the heart and soul of what we were lacking for all these years. We have these highly sophisticated modules that are automated to output these very, very extravagant types of operations like flat patterning or simulation, and we never really had a tool that efficiently helped us with those types of machines. And the simplicity of the current system, I could buy, or not even buy, I could go online, download AutoCAD Lite for free, 2007, and I could run a water jet machine efficiently. But I have nothing to structure this with. If something changes, I'm always starting over, no matter what. So I would rather take 15 minutes longer on each part than to be able to recuperate from a model change within 5 minutes than to have to reconfigure an entire sheet or several sheets. So there is an immediate ROI on going into NX CAM and utilizing feature-based manufacturing than sticking with your simple current working process. So I really want to make it apparently clear that I understand your process. I've done it many, many times. I've ran many water jet machines, lasers. I understand that the process coming out of any CAD system going into the machine controller is super simple. Why, as a programmer, would I want to put more work on myself? Because I've also been in your shoes where I had to reconfigure 15 sheets of 2,000 parts, and it's not a fun process. So to have the ability to recover, even if I never use the ability to recover, it's still worth putting in that preemptive 5-10 minutes. Then going past that and using feature-based manufacturing to automate, it's a learning curve, of course. We can help you with that learning curve. We do libraries for people all the time as service jobs, but it's critical that you go to the furthest extent that you can with your capability, because your competitor does. He is for sure calling us saying, hey, I see this come out, I want to use it. Next thing you know, your times are you can't match them, so you're not landing those jobs. So it's just a matter of keeping up with technology, and this is very important with this type of industry because we didn't have it before. Now that we have it, it's imperative that the people that are using NX for their CAD software or simulation, whatever they may use, they incorporate this as well. And then it makes it even better to incorporate it within a team center environment to where everything is managed now. So it should be a goal of all of our customers to take their software to the fullest of their capability, because it will streamline and it will bring your ROIs exponentially to a huge factor. So now let's discuss the role of PMI, because that's also very important. So PMI stands for Product Manufacturing Information. Feature-based manufacturing, it has a ton of information in the library out of the box already. So it can find just an enormous amount of feature types. It can automatically program an enormous type of feature types. But if you were to add PMI data to your process, you can refine that down so tightly that NX can understand that if it has a 10 millimeter hole, it needs to drill, and this is for a slug to fall through. It can center drill and just pop a drill through it. It could flame cut it out for all I care. You add an H7 tolerance to that. Now NX says, okay, I need to have a center drill, carbide drill, pre-bore, post-bore. We can drive all these processes off of feature-based manufacturing. We could make it as simple as numbering your exterior features with a numeral 1, your interior features a numeral 2, and whenever feature-based manufacturing runs against that, it will pull your processes, no matter how defined they are. If you're creating a part that has to have the best finish that I could possibly do, or if you're in a wire and you have to do skim cuts, or say you're in a wire machine and you have to do breakpoints to be able to put Bondo in or catch parts or something, we can automate that entire process. There's not a single thing that's on a 2-axis machine or even a 4-axis machine that we cannot automate. So it's very important to take your software to the fullest of its capability, and PMI will drive that process to its fullest. So some takeaways from today's session is, now that we have 2D nesting, if you have the sheet metal module and you have these types of machines, you should utilize it. You should also bring that into NX. Even though it works with those OEM controller logics, you're still disconnected and you're in a past technology. The moving forward technology will definitely be within the NXCAM platform and fully automated through feature-based manufacturing. The immediate benefit to the utilization of feature-based manufacturing, it potentially can be an increase of 80%. Now that we've seen this 2D, it's only been out for a very short period of time, since 2007, I believe. NX 2007, not 2007. But there's already customers that are calling us saying, we understand just by the role of this, where it's going, and we want to be right on the forefront of this. So if you have competitors that are using this technology, it's going to be a very short period of time before they're able to beat your quotes. So it's important that we all stay on the forefront of technology. And as I said, Ceratec, we have a vast experience in creating these libraries, whether that be for feature-based manufacturing or within this 2D nesting. What we like to do is we like to do a double-edged approach. If you have an immediate need, give me a list of all your features, a model that has all these feature types, a list of your processes, and in a way of past programmed parts. I will then teach the system all of these configurations, and then I'll give you 2 files. You load them into your system, and now you have that technology. But then once I come to your facility and I teach you how to use feature-based manufacturing, not teach it, just use it, then we go into a slow process of, this is what we build, this is the feature, this is the parametric knowledge, and this is how you do it sitting at your desk. So we're very successful in that. So now I'll open it up for questions and answers.
All right, thanks, Mark. Looks like we have a few questions, but if anyone has any questions now, please go ahead and enter them in the questions box, and we'll get to those right away. The first question is, how does this solve the disconnection issue that we see with our current software?
That's a very good question. So your current software, it has no care in the world. All it is to cut. That's all it does. You give it a part, you give it a profile, you tell it a few parameters and say, do it. With NX, it's built upon the associative model. So when we do this, as I said, within the CAM environment, we're now linking things to the original model. The design content is driving all past and downstream applications. Your current software is not set up to do that. It's set up to simple, just give me a program. So once we implement this higher level technology that's built upon a management system and a model system, we're now bringing this into the fold of PLM, product lifecycle management. And when we do that, we create those associative links by using the nature of the software. So we can't compare NX to any of the third-party softwares or onboard controllers because they were built just to create code. There was no higher level technology or logic implemented in the background to make things associative or have the controllability.
Great. This next question kind of coincides. Are the sheet layouts associative?
So the sheet layouts, one side of it is associative, the other side of it is not associative. So if you export a DXF file, that's not associative because as soon as you do an export, it now becomes a DOM item. All the history of that item has been erased. But if you keep it in a part file and you have all the attributes driven from PMI through design into your sheet, yes, we can do a reconfiguration just by a replace component command.
Great. It looks like that's all the questions we have for today, Mark. So as an engineering company, you can see Ceratec is focused on helping our customers realize better products through better product development experiences. We're here to help you optimize, eliminate redundancies, and create better processes. So if you need help solving engineering problems, please reach out to us, whether it's analysis, design, data management, or process improvement. Our team is ready and able to assist. We work with companies in all major industries from aerospace to marine and energy. We do small projects and major implementations too. And we help many companies realize better products, again, by improving their product development experiences. So we're here to help, and we're glad you could all join us today. If you're ready to take it to the next level, Ceratec offers much more than software. We have a wide variety of options for training, services, and 3D printers. So if you have any questions about that or any questions about today's presentation, you can email us at marketing@ceratec.com. Thank you so much for attending. Thank you, Mark, and have a great day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at ceratec.com/events.